Hello, I am Professor John Kelly, and this is the Weber Auto YouTube channel. In this episode, we are going to be removing the high voltage lithium-ion battery from a brand new 2017 Chevrolet Volt. We bought this Volt specifically for research for our automotive program here at Weber State University. So the first thing we're going to do is to go through the high voltage disabling procedure to get ready to remove this high voltage battery out the bottom of the vehicle. So the first step of the high voltage disabling procedure is to remove the key fob from the vehicle, and we've put it clear across the shop in a storage box. The second step is to verify that the vehicle still does not power on even though the key fob is out, and we have verified that it does not power on. The third step is to remove the negative battery cable from the 12-volt battery. So right here underneath the hood is the 12-volt battery on this 2017 Bolt. And the negative cable, the negative terminal is right here. The negative cable is right here. We've disconnected it and got it out of the way. If you are not aware, the 12-volt battery in an electric vehicle or a hybrid electric vehicle still powers the majority of the vehicle. The only thing it does not power, of course, is the high voltage electric motor that propels the vehicle, the high voltage air conditioning system compressor, the high voltage battery heater, and the high voltage passenger compartment coolant heater for the heater core. Other than that, the rest of the vehicle runs on the 12-volt system, which with the vehicle on, it's actually running around 14 to 14.5 volts. So that means the computers that control the high voltage battery and the propulsion system, the air conditioning system, and so on, they all run on 12 volts. The contactors, the big switches in the battery that open and close that apply this high voltage to those high voltage components are controlled by the 12 volt system. So by disconnecting the 12 volt battery here, we have disabled the high voltage contactors in the high voltage battery pack. Okay, the next step in the high voltage disabling procedure is to remove the back seat, which we've got out. I've just got it sitting upside down on the roof here. And then we're supposed to remove the manual service disconnect lever from the top of the high voltage battery. Now, if you look in here where the back seat bottom normally would go, you can see right there, there's this orange connector where the service disconnect plugs in, and there's a procedure to remove that disconnect. So the procedure is actually printed right here on the service disconnect. It tells us to turn the vehicle off, disconnect the 12-volt battery, and to see the service information. The service information tells us that we need to have our personal protective equipment on because all of the current that runs through the battery runs through this service disconnect, where it has a 400 amp 500 volt DC fuse inside of it. But the procedure tells us to get on our personal protective equipment. There's a little red connector position assurance clip that we have to lift up, and then we pinch in on this little black clip right here and rock up this handle and then pull it straight up and out. That's it. It's a fairly simple disconnect procedure. But once again, power the vehicle down, disconnect the 12-volt battery, read the service information about all this personal protective equipment and high voltage disabling procedures before you take this out. If you get the order of this wrong before you disconnect all this, it will latch a trouble code as if you were in an automobile accident. And a technician with a scan tool has got to come in to clear that trouble code before the vehicle will work again. So that's our service disconnect. Now that's out of the way, we can move on to our next step, which is to make sure that with this disconnected and everything else disconnected that we've disconnected so far, that we don't have any voltage at the inverter assembly underneath the hood on the two wires that go from the inverter down to the high voltage battery. So let's look at that next. Okay, the next step is to verify that we do not have high voltage from the high voltage battery up here to any components underneath the hood. And the way that they have us check that is to check for power on one of the electrical connectors of the high voltage battery disconnect control module assembly, this top box right here. Now there's a big electrical connector right here. This electrical connector right here also goes down to the power inverter module down below it. It just makes a big loop. And the service information instructions tell us to disconnect this connector down at the next component. But you can't get to it because there's air conditioning high side, low side pressure lines in the way. So I'm going to disconnect this one instead. And then we are going to check it for high voltage on the lines. Okay, before we take that high voltage measurement, we have to make sure that our multimeter is working properly, and we should always check that on a low voltage source first. So I'm going to come over here to the 12 volt battery under the hood. We'll just go from positive to negative. I'm reading 12.63 volts. So that tells us that our multimeter is working correctly. And when we take a measurement on this electrical connector here, we do not want to see high voltage on it, but we want to make sure that there really is no high voltage, and that's why we make sure our meter is working properly. A meter that isn't working properly may not show you high voltage when there actually is high voltage. So our meter is good. We're going to take this connector off. This connector has a lock release cavity right here. We'll just come in with a little screwdriver, put it in the hole and pry it out a little bit, and then we'll just rock it out like that and pull it straight back. Okay, with this electrical connector disconnected, we can check for voltage not on the harness that we just disconnected, but on the module that we disconnected it from, because that module is supplied power from the high voltage battery underneath the car. So if we don't have high voltage on this module, on these two pins here, then we can be sure that the contactors in the high voltage battery are open as they should be. They're controlled by the 12 volt system, which we've already disconnected. And then we can go down and disconnect the big electrical connector at the battery and drain the coolant and take the battery out. So let's take some measurements here. There are 3 measurements we're supposed to take. We're supposed to check each of the 2 electrical terminals here to ground, chassis ground. I'm reading 30 millivolts on that one and dropping, and the one down below 0 volts, and then the 2 terminals together 0 volts. So we have no volts, and so then we're supposed to check the same thing on the electrical connector that we disconnected. So now we go from one terminal to ground, we have no voltage. The other terminal to ground, no voltage. And then the 2 terminals to each other, no voltage. Okay, that tells us that the contactors in the battery are most likely open, but we will verify it one more time down at the battery when we disconnect that electrical connector. So let's go do that next. Okay, here we are underneath the vehicle. This big black housing right here is the high voltage battery, and right here in the front of the battery we have the charger connector right here. When the battery charges, it charges through this electrical connector right here. We have 2 coolant lines for the temperature control of the battery, the heating and the cooling of the battery. And we have the great big electrical connector right here that feeds power to the inverter module that then drives the traction motor up front here. And then we have 2 low voltage connections over here and a couple of ground straps. So the disconnect procedure continues with checking to make sure we do not have high voltage on both the large electrical connector and the small electrical connector. So the procedure is to release the connector position assurance clip and unplug the charger connector. And then using the same multimeter, a category 3 meter with category 3 leads. Right here they're category 4. I have to turn the twist lock there to get them to be category 3. And we will check, let's see, it has us check the battery pack connector first. So right here in the battery pack, we will go from one terminal to ground. We have 0 volts. Another one to ground, 0 volts. And then terminal to terminal, and we have 0 volts. And then we're supposed to check the harness side also. Terminal to chassis ground, 0 volts. The other terminal to chassis ground, 0 volts. And then terminal to terminal, 0 volts. So there's nothing there. I don't need personal protective equipment around this electrical connector right here. And then we'll do the same thing to the big electrical connector over here. So we'll come in and release it just like the one up above. It's the same connector. We'll swing out the lever, pull back. That unplugs the high voltage connector. And then we'll go from terminal to ground, 0 volts, terminal to ground, chassis ground, 0 volts, and terminal to terminal, 0 volts. So there's no power available at the battery electrical connector here because the contactors are open inside the battery. And then just to make sure we don't have any high voltage from a capacitor that isn't discharged in the inverter assembly, we will go from, and I'll have to change my meter leads to category 4. One terminal blade to chassis ground, 0 volts. The other terminal, 0 volts. And then terminal to terminal, 0 volts. So at this point, we have no high voltage anywhere here, and I'm going to take off my high voltage gloves because they get hot, they're awkward to work with, and if you don't need them on, you don't need them on. All right, so the next steps are to disconnect the 2 electrical connectors here. We've got 2 low voltage connectors. Each one has a red terminal position assurance clip and a little pin that we compress and take out. We have two bonding ground straps here that we need to disconnect. But before I do that, we've got 2 coolant lines over here that need to be removed and drain the coolant out of the reservoir and the lines, the pump, and out of the battery itself. So I'll get a drain and let's get draining this coolant. Okay, I'm about to drain the coolant out of the high voltage battery here on this 2017 Bolt. But I wanted to show you how much coolant came out of the Chevrolet Volt. We have a 2018 Chevrolet Volt right over here that I've taken the battery out of, taken it totally apart. I have a separate video on that. But the entire cooling system, the reservoir, the hoses, the entire battery, and all the coolant plates held less than 1 gallon of coolant. That's all that came out of that thing. I was very surprised. It'll be interesting to see how much comes out of this Bolt battery here. but I don't think it's going to be some tremendous amount of coolant. I have not looked up actually how much it's supposed to hold, but let's get this draining. The coolant, by the way, is not reusable. If you saw those little coolant plates in the Chevrolet Volt video, you know they're very tiny, and the slightest little piece of dirt or dust from a rag or a cloth or anything that gets in there can plug those up. So always use new coolant, always dispose of the old coolant. I've just not disposed of it yet because I wanted to show my students how little of an amount of coolant came out. All right, I've got the official battery removing powertrain removal tool here. It is an electric scissor lift, as you can see here. This is the same one that I used to remove the Chevrolet Volt battery. There is not a special holding fixture for the Bolt battery. It just sits on top of this platform here. But for the moment, I'm going to raise up, it's electric, I'm going to raise up this powertrain lift so we don't get very much splashing out of those coolant hoses, and I'll get that draining here next. There are just two little clips that hold the coolant hoses in place. We'll rock those out of there. Here's one of them. And here's the other one. Now, these are a quick connect fitting on the battery. This is a second design battery in the Bolt. The second design has both a male coolant hose connection right here and a female connection. The male connection is on the inlet, the female connection is on the outlet. So if you want to know if you have a first design battery or a second design battery in the 2017 Bolt, that's how you tell. Now if I can slowly get this out of here without making a giant mess. Here it comes. And then we'll get the other one off of there. As you can see, not a lot of coolant has come out. Now that doesn't mean all the coolant has come out of the battery. There's a procedure where we put a vacuum on the inlet port and pull out the rest of the coolant that's in there, but it's not going to be very much coolant. I'm going to let down the powertrain lift here. I can see that the reservoir is empty from the bottom here. Let's take a look at these coolant connections. So as you can see right there, there are the two coolant fittings for the battery. The inlet receives the male fitting from the hose. The outlet receives has the female fitting from the hose. And of course, they're just the opposite fittings on the battery itself. So no more coolant dripping out of there. As you can see in our tray right here, we did not increase the volume of coolant very much. All right, I'm going to undo the two bonding wires next and plug the coolant hoses so we don't have any more coolant come out. All right, I'm going to take off the two ground straps, the bonding straps. Get those out of the way. Put the nuts back in the proper locations. And now we are ready to take this battery down and out. Okay, we're ready to take this battery down. The lifting table that I have here needs to be placed right at the center of gravity underneath the battery. And that center of gravity is actually marked with the letters CG and a little dot right in the middle of the, not in the middle, but in the center of gravity of the battery. So the CG mark is right here. And so we want our lift table to be as centered as possible in that area. So I'm going to lift it up and position it there. By the way, this battery weighs 1,000 pounds. This powertrain lift is rated at 2,500 pounds. Looks like I'm off to the side a little bit. Need to pull it over. That looks good right there. Okay, I've got the powertrain lift right up against the bottom of the battery. We're ready to take the bolts out that hold it to the vehicle. I'm going to lift up a little bit more because it kind of sagged down a little bit when I took that last bolt out. And then we've got one more bolt right there. Okay, there's nothing holding the battery into the vehicle now except for this powertrain lift. So it's time to let it down real slow. Looks like I've got one harness that was clipped to the battery. We'll make sure everything else is out of the way. Now we're just going to let it down real slow. Looks like it's tilting towards the front. I just need to adjust the powertrain lift to level it out a little bit. Alright, so we want it to tilt a little more that way. There we go. Okay. Now it feels a little more stable. It was tilting forward there. Okay. Ready to let it down a little bit more. Looks like it's pretty stable. I'm pretty nervous letting this battery down because there's absolutely nothing that holds it positively to the powertrain lift like the Chevy Volt battery had a special tray. This one does not. I put a piece of rubber between the metal top of the powertrain lift and the metal bottom of the battery to try to prevent it from sliding, but that's the procedure. So it looks like it's coming pretty well. I just got to make sure that we're not dragging any electrical connectors or coolant hoses down with it as we let it down even more. Put this up on top. Looking good. Let's continue letting it down. Wow, that's pretty thin. That's thinner than I thought. Very cool. Okay, well, let's roll this thing out and take a look at it. All right, here it comes. Okay, we finally got that battery out. Wasn't too bad of a job. Let's take a look at the battery housing. It's a little easier to see the electrical charger connector right there, the two cooling passages, the inlet on the left, the outlet on the right, the high voltage connection that connects to the inverter to drive the traction motor, the two low voltage connections for internal connections to the temperature sensors, the contactors, and so on inside of the battery. It has kind of a fiberglass cover with a steel bottom. These big steel supports here that bolted it up to the bottom of the vehicle have a place to put some eyelets through there for a lifting adapter to swap out a replacement battery if necessary. We have several labels on here. This one tells us that it's made by LG Electronics. 57 kilowatt hour. Vista 2.0. I'm pretty sure that means it's the second version. We've got a sticker telling us not to stand on this case. We've got another sticker showing us where to hook the support fixtures to lift it. And then we have another label that gives us warning information about the battery and disposal information. Then here in the back of the battery, we have several battery modules stacked on top of each other under this cover that we will see in the next video when we disassemble the battery. We've got another label right here. I don't know what that is. And then on the very back of the battery, we've got two more labels. And then we have our service disconnect connector right there. And as I showed you when we took the back seat out, we've already removed the service disconnect that open circuits the battery internally. So let's do one more roll around the battery to get finished up here. It's much thinner than I thought it would be. The big bump at the back here is under the back seat, so it has more room. And now let's go under the vehicle and see where the battery was mounted before. So you can see this big dip area right here. We've got the hole where the back seat was that allowed us to access the service plug. And then we've got a recessed area here where the rest of the battery sat. Then we have our two ground bonding wires, our two low voltage connectors, our single high voltage connector that goes to the inverter assembly to drive the electric motor, our charger cable. And this version of the bolt we did not buy with the fast charger option. I wish we would have, but I don't know. I will have to look to see if it has bigger terminals for the fast charge or not. And then we have the outlet terminal and the inlet hose and the outlet hose right here for battery cooling. While we are under here, this module right here is the battery coolant heater. We've got the air conditioning compressor that also cools the battery coolant. We've got our traction motor, differential, half shafts, steering rack. For some reason, our steering rack is leaking. It's a brand new bolt. There is no, it's got like 30 miles on it. And it's dripping oil. You can see right there on the back of the steering rack. It's dripping oil down. And right here also. I have no idea why. When we take this whole cradle down to remove the traction motor and everything else, in future videos we'll investigate it and see what's going on. It's probably just a O-ring that got cut when they installed or built the rack. We'll get that fixed. Okay, well, that was quite the adventure, removing the battery from our 2017 Chevrolet Bolt, brand new. It's got like 35 miles on it. In the next video, we will take the cover off of this and disassemble the battery totally. I've got the proper fixture and lift to take each battery module out. We'll strip it clear down to a bare housing and put it back together and investigate all the internal parts, just like we did on the Chevrolet Volt battery deep dive. And then we'll dive deeper into the rest of the Bolt high voltage system and other operations as well. For those of you with the Chevrolet Volt, I have not forgotten about the rest of the videos I'm going to do on our 2018 Chevrolet Volt. I've had the flu really bad for several weeks, and it's put me behind here in my work at Weber State University. So we will catch up as soon as we can. Thank you for watching, and have a good day.